Explain the term circumference. Now, so they just want to know, what do you understand when you hear the word circumference? Circumference is the distance, the total distance around a circular shape. So 3.1.1, circumference is the total, the whole thing, distance. Remember, circumference is a distance. Also important to write that. Around a circular object, right? Or a circle. So I don't know why I went for circular. 3.1.2. Convert the length of the rectangular pool to meters. Okay, so before I convert the length of the rectangular pool, what is the length of the rectangular pool? So if you go there, it says length, which is the longest distance, is 40 feet. But if I wasn't given this, I would be able to see it on the drawing. The length is the longest distance there, which is 40 feet. Now they're saying, please change this to what? To meters. And then we come here. 1 foot is equal to 0.3048 meters. So if I have feet, I can change them to meters. And if I have meters, I can change them to feet. So how do we use this? You're going to see now when we do 40 feet. Before I answer any conversion question, I always write the one that they said there's 40 feet and they want me to change it to meters. For my convenience, I write that. And then I say, okay, what do I know? They've given me that 1 foot is equal to 0.3048 meters. This I know, right? I know this. They've given it to me. So I'm changing 40 feet to meters, right? So where did I write feet? On the left, and where did I write meters? On the right. And I'm going to do the same here. Start with the is equal to. Then I say, what do I have? 40 feet. Where's feet? On the left. So I write the 40 feet. Right? And then on the right, I have meters, but I don't know how many meters is 40 feet. So for me, I like to write unknown yet. It's not known yet. Okay, so now I cross multiply. Cross multiplication is learned in the lower grades. But I'm going to keep doing it until those who want to know it are familiar with it. 1 foot times unknown. So I took this 1 foot and I followed this line here, and it says I must multiply with unknown. And then I write is equal to. And then I come back and say 40 feet, follow the line, and on the other side at the top is the number to multiply. I'm here. So here is my unknown, which I'm trying to figure out. And on this left-hand side here, it's sitting with 1 foot, right? And they are multiplying each other. In order for me to move this 1 foot to the other side, crossing the bridge, as my primary school maths teacher used to say, it has to change the sign. So this time it's multiplying, and therefore what is the opposite of multiplying? It is divide. So you divide by 1 foot. Then that is dividing that, and then we are left with just one unknown. Now remember, whatever you do on the left-hand side, you have to go and do on the right-hand side. So I divided by 1 foot, and therefore now we'll check it out. Where is 1 foot now? It's no longer on this side. It went on the other side, and it changed from multiply to divide. Okay. Now, all I have to do is just finish this up by saying unknown is equal to 40 feet times 0.3048 divided by 1. We were calculating the meters. On this side, it's meters. So this one's going to come out as meters as well. Just check. If you divide this by 1, nothing happens, right? Stays the same. Okay. 3.1 point. Oh, it's not 3.1 point. It's 3.3. Yes. Okay, Mrs. Palazzi claims that Mrs. Palazzi claims that pool A can hold over 169,000 liters of water. So basically, she's saying the capacity, that's what she's saying. They are not saying that, but she's saying it. She's saying the capacity of the pool, this one, is 169,000 liters, right? And then if the volume of the water for section A of her pool is given as 84,951 liters, determine whether Mrs. Palazzi's claim is correct. So they are giving us the volume for section A only. So they're not giving us section B, right? They're not giving us section B. They're just giving us the volume for section A, and they are giving us the capacity for the entire pool. Now they want us to prove whether this water will fit into this pool, right? So basically, what we can do, so I want to know how many liters go to section B. And here, I'm just going to go ahead and say the height of this triangle is this one, which is 6. And the base, look at that, the base is 40 feet. If you look at the pool here, it is a triangular shape here, which means the pool is only half of an actual box, right? So it's cut, but it's cut diagonally like a sandwich. So what we're going to do for 3.3 is actually pretend as if this is an entire box. And then what we're going to do is, after calculating the volume, we're going to say that we just calculated the volume for a box that is a rectangular box. But now our box is not a rectangle. It's actually a triangle, which is half of the entire thing, right? And then we're going to divide by 2 and get this part only. Let me show you how we do that. Using a formula, the first thing I'd always do is check my units of measurement. So this one, the height is 6 feet. And I'm already like, no, they didn't say calculate the volume in feet. They didn't say talk about that. And I need to change liters, volume to liters, so that I understand what I'm talking here. So I'm going to need cubic meters anyway. So I already see first that I have to change feet to what? To meters. So 6 feet is going to have to be changed, the height, the length, the breadth also, right? Because the formula for volume, I'm just going to write it here so that we can see what we're talking about. Volume of a rectangular box is equal to length times breadth times height, right? So my length is in feet, my breadth is in feet, my height is in feet. Yes, they are all in the same units of measurements, but they're in the units of measurement I don't want to use. So I'm going to change all of those to meters. So I'm changing 40 feet to meters, and I'm changing 25 feet, which is the breadth, to meters, and I'm also changing 6 feet, the height, to meters, right? Okay, so that would be length times breadth times height. It gives me the volume for the entire box, including the part that we're actually not using. For now, we're calculating the whole big section. Okay, so 40 feet I don't have to change because I did that in 3.1 already. They said that 40 feet is actually equal to 12.19 to meters. Oh, I hope I don't make a mistake. Now we're going to change 25 feet. And so if we do that, we're going to say 1 foot is equal to, remember they said 1 foot is equal to 0.3048 meters, and then is equal to, then we're changing 25 feet, and feet are on the side, and then we don't know how many meters it is. That's why we're calculating it, cross multiply. Let's do cross multiplication one time. Okay, 1 times unknown, 1 foot times unknown is equal to 25 feet, this one, times 0.3048 meters. Right, now we're here, we're going to say we want unknown, so we must make 1 foot for that side. Therefore, it's sitting with unknown, and they're multiplying each other. What is the opposite of multiply? Divide. 1 foot, and that cancels that, and then what you did this side, you go and do on the other side, divide by 1 foot, and voila, it has crossed the bridge, and now it's appearing on the other side. The next part is just a calculator. 25 times 0.3048 divided by 1, not making any difference, it's 7.62 meters. Very good. Okay, so next step is 6 feet. 6 feet, I already know that I have to multiply it by, so I'm just not going to do the calculation here. It's 6 times 0.3048. If you're afraid you're going to make a mistake, then you do it. So 1.8288 meters, right? Okay, so now we can calculate the volume, which says volume is equal to length times breadth times height, right? And then we're calculating for volume. The length is 12.192 meters multiplied by the breadth, which is 7.62 meters, multiplied by the height, which is 1.8288 meters. Our volume is 12.192 multiplied by 7.62 multiplied by 1.8288, and we get 169,9010796. That will be cubic meters, and I'm going to divide this by 2. Oh, I should have done this below. If I divide this by 2, then I get the volume for the triangular part, which is 84,95053978 cubic meters. The reason I don't want to round off is because I'm still using these numbers, so I don't like rounding off before finishing. Okay, so now the next part is I need to understand how much water is going here. How much? Yes, now the volume is 84.95 cubic meters, this space, but how much is the water that's coming in here? To find that out, I have to say 1 cubic meter. 1 cubic meter is equal to 1,000 liters. So if this was only 1 cubic meter, we will have only 1,000 liters going in there. But we don't have that. We actually have 84,95053978 cubic meters, and we don't know, and we cross multiply. So one last time, 1 cubic meter multiplied by unknown is equal to 84,95053978 multiplied by 1,000 liters. And then you divide that by 1 cubic meter, that cancels that. And then whatever you do on the other side is divide by 1 cubic meter, and you press your calculator times 1,000 will give us 84,950,53978 cubic meters. Now, we're not done. This is 8 months. We come back here to the drawing and we say we have the water for section A, we have the water for section B. What is the total? So let's add them together. The water for section A is given here as total water is equal to 84,951 liters plus 84,950,53978. This is wrong. This is liters. Right. This part here is wrong. It's actually liters. Okay, so that'll be liters. Okay, so now we just add the two. So, okay, she says, Mr. Fulana claims that pool A can hold over 169,000 liters. Hold over. It can hold more than 169,000. And yes, she's right. You can put in about 2 liters more than that. You can put in about 901.5 liters more than that. So I'm sticking to my guns and saying she is correct. Oh, that took forever.